Hey everybody, this is your basic statistics review. We're going to cover a few things in here, but a lot of it will be review for you. These are types of graphs you've seen before. We've got circle graphs. They're used to show the results of an investigation in a proportional manner. So you're dealing with 100% and you break down the thing in different percentages, but they should add up to 100. Bar graphs are used to compare variables. They plot categories of data, like types of cars. You would have a sports car, a sedan, SUV, a van. They're all cars, but they're categories of cars. Histograms are used to show distributions of variables. They plot quantitative data with ranges of the data grouped into bins or intervals. So, quantitative means counting quantity, and so you would have 1 to 3 of these, 4 to 6 of these, 7 to 9 of these. You would have intervals, and they should be equal intervals. Box and whisker plots are used to summarize data and to illustrate the variability of the data. How far does this stuff vary? Was it low? What's the high? What are the middle numbers? Everything else just shows what is. Box and whisker plots actually show the variability. Here's what they look like. Okay. Right here on the left corner, you have the bar graph. Apples, different fruits. Apple, oranges, bananas. Winning scores. Okay, 10 to 20, 20 to 30. That's the histograms. Your circle graph right here, 25, 55, 80, 100. Adds up to 100% favorite type of movie. So it's all about a movie broken down in proportions. Right here is the box and whisker plot. Here is your lowest point, your highest point, and that's your median, your middle point. That's just which one is the middle of the data. All right. And here's the box and whisker plot broken down for you with each thing. You've got the lowest right here. That is whatever it is. It could be very low. This is your lowest value. Q1 is the middle number between the median and the lowest number. Okay. Q2 is your median. Make sure after I misspoke you get that median. Q3 is the middle number between the median and the highest number, and then your highest value. I do have videos where you can get these numbers off of Desmos, so you don't have to come up with them on your own. Q1, Q2, and Q3, those are called quartiles. Q3 minus Q1 is called the interquartile range. And you've got a semi-interquartile range, dividing that by 2. Outliers are numbers that lie 1.5 times the interquartile range below Q1, or 1.5 times the interquartile range above Q3. So you may have on your box and whisker plot this highest value, and then you may have a couple of dots out here, or you may have the lowest value and a couple of dots down here. Those are where outliers. All the data's in between here, but then you've got some outliers. Okay. Measures of central tendency. What happens in the middle or the center of the data set. Mode is a useful average when analyzing data on something like clothing or package sizes. So you would have the most frequently used size. They sell shoes that way. In women's shoes, they sell very few 4s and 5s, a lot of 6s, 7s, and 8s, and then a few 9s and very few 10s, 11s, or 12s. So they group it according to what shoes sizes people are, women. The median is useful when discussing something like salaries or home prices. It's not affected by a few outliers in the data set. And the mean is useful when discussing something like sports statistics or scores, where all items of the data set are equally important. You have to have even your outliers in sports statistics or the scores. Variability is how much do the items in the set vary. So, central tendency, this is all discussing the middle and the center. Variability is discussing ranges of stuff. How far does this stuff go? The range is your difference between the highest value and the lowest value. The standard deviation is how much would we expect each value to vary from the mean. The standard deviation is widely and frequently used in statistics studies. Okay, yeah, standard deviation comes up an awful lot. A basic or typical standard deviation problem is as follows. The number of hours that a student works after school per week has a mean of 11 hours and a standard deviation of 2. Find the range of hours within one standard deviation and the range of hours within 2 standard deviations. Normally, you will find this on something standard deviation curve. It's called a bell curve also. Your mean is right in the middle. Pretend I can draw. There's the mean. And that would be 11 hours. One standard deviation up this way is this, and you got it like this. One standard deviation in this direction, and you got it like this. Okay, if the standard deviation is 2, that means we're going to subtract 11 minus 2. And then on the other side, you're going to add 11 plus 2. So one standard deviation would be from 9 to 13. Just like I got here. That is one standard deviation range. 2 standard deviations. Well, you're going to do it again. This would be minus another standard deviation. And this would be adding another standard deviation. So 9 minus 2 at that point is 7. 13 plus 2 is 15. We also did down here 2 standard deviations. So 2 times 2 is 4. 11 minus 4 gives you the 7. And 11 plus 4 gives you the 15. Whichever way you think about it is fine. If you just count down 3 standard deviations, then minus 2 again would be 5, and add 2 again would be 17. That's 3 standard deviations. Okay. These percentages you need to know. They tend to always come up. 68.2% of the data falls within 1 standard deviation of the mean. 95.4% of the data falls within 2 standard deviations of the mean. And 99.7% of the data falls within 3 standard deviations of the mean. So they're talking about this right here. That's 68%. You add these two, and that becomes 95%. Add these 2 sections, and that becomes 99.7% of the data. Okay. And last one on this video. The scores on an exam have a normal distribution. The mean of the score is 50 and the standard deviation is 6. What is the probability that a score chosen at random lies between 62 and 68? Well, you can draw your own little normal curve. And your mean is 50 and the standard deviation is 6. So we'll go up 6 to 56. And we'll go down 6 to 44. Up 6 again is 62, and down 6 is 38. And I just see that I've got a mistyping there. That should be 38. Okay, so what is the probability? Well, that is 2 standard deviations right there. 2 standard deviations. So that percentage is 95.4%. Okay? And this one says 95.4% of the scores on a standardized test range from 60 to 88. What is the mean and the standard deviation? Okay, well, in this case, you are working backwards. They don't have the mean, and they don't have how much we're going up. But they did tell me it was 95.4%. So that is 2 standard deviations from that mean. Okay? So, whatever the mean is, plus 2 standard deviations equals 88. And the mean minus 2 standard deviations equals 60. So, you can actually figure out what's between them by adding them up. They will cancel out, and you'll have 2 times the mean equals 148. When you divide by 2, then you've got the mean equals 74. I think actually that's the first time I've ever done it algebraically. What I usually do is say 88 minus 60, well, that is 28. Okay, I've got 4 places from 28. That means each of them is 7. So I found my standard deviation of 7, and I've got 88 minus 7 would be 81. 60 plus 7 would be 67. 67 plus 7 would make that 74. So you can also split it up that way, more of an intuitive type way to do it than actually doing it algebraically. But either one works. So, that will end this video, and the next thing we'll be doing is some misleading statements.